Hello everyone, today we are going to start a new topic, that is the motion under constraint, which is in the chapter laws of motion. Now from the laws of motion we get the idea of the motion of the object. That means how we can explain the motion of the object with the help of the Newton's laws. Now constraint word means the conditions. So what happens? Sometimes the objects do not freely move in nature. What does it mean? It means that sometimes the motion of the objects is restricted or controlled by certain conditions. Like when the example of the motion of the objects connected with the ropes, pulley, etc. As an example, we can mention one example of the pulley system. What is that? See here, if a block is attached to another block by using a string, where the string is passed over the frictionless pulley, then what happens? If suppose this block is moving in the downward direction with an acceleration a, so definitely the motion of this block depends on the motion of the other block, because it depends whether the second block is moving in the upward direction or downward direction. Without mentioning the motion of the second block, we cannot understand how the first block will move, right? So this is one of the example of the motion under constraint, where one block is connected with the other mass by using a string or ropes. So here we are going to discuss about the ways in which we can explain and analyze the motion, and ultimately to find out the acceleration of these blocks in a particular system under constraint. So let's see. First we talk about the one simplistic system, acute machine. Which actually basically contains two masses M1, M2 block, which are connected to the rope or the string, and the string is passed over the frictionless pulley. So if we consider that the mass M1 is moving in the downward direction with the acceleration a, so another mass will also move in the upward direction with an acceleration a. And what happens when we consider that this mass is moving in the downward direction? Then weight of M1 is acting in the downward direction, and this weight, because of this weight, the string will feel an opposite reaction force, tension force. And similarly, this mass will have the weight also, which is the M2g, and again the string will feel the tension force T. Okay. Now, since the string is taken as the same, in a same string, tension force remains same, because the string has been passed over the pulley, so definitely the same string has been used. So the tension force for both the part of the block will be same. Now this is a very easy example. We can easily understand if this mass M1 is moved in the downward direction by a displacement x, so definitely this mass will move in the upward by an same displacement in the upward direction. There is no confusion, and as a result same acceleration will be there also. But the problem starts when instead of the fixed pulley we also attach one movable pulley. Yeah. Let's see. first of all, we start with this condition. Here goes one fixed pulley, and here we have taken a movable pulley. Okay, this like this, and here one block is attached, and from here another block is attached. Suppose this mass has the 2 kg and this mass has the 1 kg. Clear? Now this pulley is the fixed pulley. Okay, and this pulley is the movable pulley, because it can move in any direction, in the upward or downward direction. Movable. Okay, now see here. Now since as I have said earlier that the tension force will be same throughout the same string. That means because of this weight, the tension force, suppose let's see, here also same tension force will be in the upward, because the weight of the block is in the downward, and here also same tension force is applied in the upward direction. Now see, let's consider that the mass 2 kg is moving in the downward direction with an acceleration u. And similarly, if this block moves in the downward direction, definitely this block will move in the upward direction also. So let's consider this block is moving in the upward direction with the acceleration u. Now see, unlike the previous case, here acceleration for both the blocks of the 2 kg and 1 kg will be different. The reason is simple. Why? Suppose this block moves down by an displacement x. So immediately this string has been moved down by x. So definitely we can say the entire string and pulley system will move up by x, right? But the problem is this part and this part of the string, they should move up equally, equal portion. But entire displacement is only x. So x is divided by 2 parts. Here it will be x by 2. Here it will be x by 2. So definitely this acceleration will be different compared to this one, because displacement for both the blocks are different also. Here it is x. The complete system is moving up with the x displacement in the upward direction, but this portion and this portion both are moving up by an equal amount. So this displacement divided by 2 will be the x by 2. So definitely here displacement will be different. So let's see, we can find out how we can find out the acceleration of both the pulleys. Now before that, let's see here in the upward direction is the tension force, here tension force. So both the string will have the tension force in the upward direction. So this will be the T plus T 2T. Okay. Now let's see how we can solve this without measuring the displacement from both sides. Let's see. For this we will say that total internal tension, total internal work done by tension force is 0. Tension is a force here, and the block is moving in the downward direction by displacement. So definitely what is done, tension force. Okay, and since we are not applying any external force from the outside, so the tension forces are internal, and total internal force is always becomes 0. Now what is the amount of the work done by the tension force? That is the tension force multiplied by displacement, work done, for this block plus for this block. What is this? Let's see. T1, let's say T1 and T2 are the tension force for block 1 and block 2. That means for this block and this block, the tension forces are T1 and T2. T1 and T2. Let's see, consider. And also x1 and x2 are displacement of block 1 and 2. That means x1 is a displacement for this block, x1, and here for this block it is the x2. This block moves down by x1, tension force is T1. Suppose, let's consider this block moves up with the displacement x2, tension force is T2. Okay. Now work done by this tension force for this part, T1 multiplied by x1 plus for this block T2 multiplied by x2 equal to 0, because total internal force is 0. Okay, so from this we can write summation of T1 dot x1 equal to 0, because we know that the work done is always dot product of the force and displacement. So we have taken dot product of the T1 dot x1. Now if we differentiate on both sides, so we can write T1 here, T dot x. We can write T dot v equal to 0. Similarly, again, if we differentiate again, we can write summation of the T dot a. Okay, because if we differentiate the x, we get the velocity. If we again differentiate v, we get the acceleration. So finally, what we need to find out the acceleration is the sigma of the T dot a, where a is the acceleration. Okay, so this is the formula we have to use to solve this problem. Let's see how we can do it. Okay, formula that T dot a equal to 0. Now for each block we have to write the value of the T dot a. So let's consider for this block, what is T? T is here. Acceleration, let's consider here acceleration is the A. A1. Okay, A1. T A1. Now the most interesting part. What is the direction of the T? Upward, right? What is the direction of the acceleration? Downward. So what is the angle between the tension force and the acceleration? 180 degree. That means cos of 180. Dot product T A1 cos of 180. Okay, next for this part, T2 is in the upward direction. T2 is in the upward direction. See, T2 is the 2T here, T plus T. So you write 2T. Acceleration is in the upward direction. So you write 80. Now tell me, what is that angle between the tension force and acceleration? See, tension and acceleration both are in the same direction. So angle is 0. Now let's see. Cos of 180 is -1. So minus T A1 Now the relation between the acceleration of the both the block is the A1 equal to A2. A1 is this one, A2 is this one. Now next we have to find out the tension force. How can we do it? By finding out the FBD, the free body diagram. So again we'll use the block by block for this one. For this block, the tension force is the T, and acceleration weight is the 2 into G. Acceleration is the downward. Let's consider A is the acceleration for the block of 2 kg. Okay, 2 into G, mass into G. So mass is 2 kg multiplied by G. So here we can write downward C. Net force is in the downward direction. So we will write the downward force minus upward force equal to m into a. So minus T equal to mass is m 2 multiplied by a. Okay. So T is equal to 2 G plus A. Here in this way you can do it. Now similarly, if the acceleration for the mass of 2 kg is A, then acceleration for 1 kg, what will be this one? See, A1 is equal to, so A2 is equal to A1 by 2, A by 2. So you can easily find out the acceleration for the second block. That is the, if the A is the acceleration for the mass of 2 kg, then acceleration for the 1 kg will be the A by 2. That's it. By using this method, we can easily find out the acceleration for any kind of system for this constant motion. Let's take another example. So here there is a block and there is a fixed pulley. There is a mass is attached. So here and the pulley goes here. So here attached. Okay, so here now this mass is M1. Now see again the weight is in the downward direction, that is the M2G. Tension force T. Same string, that means tension force here. And same string here, so tension force again T. T plus T, so this tension force will be 2T. Now if this mass is in the downward direction, the acceleration A1, A2. Let's consider A1 is the acceleration for the mass M1 moving in this direction. Okay, let's see. Now we have formula T dot A is equal to 0. So now for the block M1. Now see here. T dot A. T is the 2 multiplied by A1. TA cos theta. Now both are in the same direction. Angle is the 0 degree. So 2TA1 cos 0. Cos 0 is 1. Next. Plus for this one, tension is the T. We write T multiplied by A2. And now see, T and A2 both are in the opposite direction. Opposite direction means angle is the 180. So cos 180 means minus 1. T cancel out. So you can write A2 equal to 2A1. See that you can easily find out now acceleration for both the pulleys. That means if I say that if M1 is moving with the acceleration A, so A2 will be the 2A acceleration. So again we can use the APD, that means T minus N2G equal to this one. Okay, let's try another one. So today we are just doing only the acceleration. We can always find out the net force, the tension force, what is the amount of tension force, and what is the acceleration of A2. So let's see another one. Here and block number 1, blocks number 2, this is the mass M1, this is the mass M2, and here this is moving it is attached to this pulley like this so this pulley again attached the okay this again. Okay, now the question is that this block is in this direction with the acceleration 6 meter per second square, and tension force is then T1 T. So question is, what is the acceleration for this mass M? Both of them are in the frictionless surface. Now let's see. This block is moving in this direction with the acceleration 6 meter per second square. As a result, since this is tied with a string, the tension force will be applied on the string also. So movement is this one, tension force will be acted on this one. Again, Newton's action reaction pair, if the tension force is acted on this direction, so exactly the equal amount of the T will be applied in this direction. So here also tension force, here tension force, here. Okay, now see, tension force here, 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 here. Because of this, got it? Now let's see. Okay, so it is actually attached to this one. Now let's see. Here again we will use the same condition E dot A. So for the first block, tension force will be this much. This plus this. Okay, this plus this plus this. Here, because this is attached to this one also. This one plus this one plus this one. Okay, T plus T plus T. Because this is divided into two parts. So T plus T plus T, T multiplied by A. Suppose we write A1 and is A2. Okay. Now you can see that moving, this block is moving in this direction. Tension force is also in the same direction. Okay. So 3T A1 into plus for the second block. For the second block, what we will do? A2 is the acceleration in this direction, and tension force is in this direction. So you can write here, see that this is attached to this part and this part only. So T plus T here. Now tension force is in this direction, acceleration is in this direction. So 2T into 8 minus 1. Why minus 1? Because acceleration and tension force both are exactly opposite to each other. So definitely again cos 180 equal to 0. So from this you can write tension force cancel out. So A2 equal to 3A1 by 2, right? A2 is equal to 3A1 by 2. Okay. So A2 is 6 meter per second square. So you can find out the A1. Let's see. So A1 is the 2A2 by 3. So 2 by 3 multiplied by 6. 4 meter per second square is the answer. That is the acceleration for this block is the 4 meter. Yeah. Let's try another one. More you can practice, more it will be easier to do this kind of sums. Now let's see another one. Another one will be this one. Here is a block placed on the surface. This block here. This is attached here. And okay, this is a block M1, and here another block is attached in 2. So here this is moving in the suppose acceleration 8, and as a result this is moving along this direction with acceleration E1. Now tension force is T, same string, so tension force, action, reaction force, T is the action along this direction. As a result, reaction force is being applied opposite direction. Same string, again tension force will be applied, because more we move this direction in the downward direction, more it will move in this direction. As a result, this string here also feel the tension force. Now see, tension force here T, T. So these both the tension force are equally responsible for motion of this block. So we have to add T plus T to get the total tension force applied on this one. Okay, now see that. Again, we'll use the T dot A equal to 0. So for the first block, tension force is the 2T along this direction. 2T multiplied by A1. Okay, plus again both the same direction, that means the angle is 0, so cos 0 is 1, plus for the block 2, tension force is T, acceleration A2, but both of them are moving exactly opposite to each other. That means cos of 180. That means minus 1 equal to 0. So tension force cancel out. So A2 equal to 2A1. A2 is equal to 2A1. That means whatever the acceleration of this block is, the double will be here. Okay. Okay, now let's try another one.